This is an atom of magnesium. Okay, if we look on the periodic table of elements, we see that magnesium is located in period 3 and it is in group 2. Okay, if we look at magnesium, okay, this is the box on the periodic table that has magnesium in it. There's so much information there. Okay, the actual symbol of the element is the largest thing. It is here. Okay, and the name is usually below it. Most often the names are in Latin. Okay, now there are 2 sets of numbers here. All right, and that's what we're going to start to talk about. We're going to start talking about this first whole number, the number with no decimals. Okay? If we look at the red little dots and the inside and the centermost part of this atom of magnesium, okay, these red dots, there are 12 of them, and they correspond to this actual number up here in the top corner. And that number is called the atomic number. And your atomic number is always going to be equal to the number of protons in your atom. Protons, okay, in an atom carry a positive charge. All right, they're happy-go-lucky. They're like joy on inside out. They're always happy, positive. Okay, they are positive charges. Now, the plus VE is just shorthand for positive. Now, you'll notice that there's another color of particle on the inside of the nucleus, and I'm going to get to that last. The second thing I'm going to talk to you about is a particle that is actually not really solely identified in this box, but is super important. Okay, in the world of particles. It's actually the reason that the lights go on when you flick a switch. All right, it's a particle known as an electron. And electrons don't live in the centermost part of an atom. They actually live in these rings or orbits. These rings that surround the centermost part of an atom are called orbits or electron shells, one or the other. Okay, you can refer to them as orbits or electron shells. And here's the cool thing about an atom. The number of protons in an atom will always equal the number of electrons in that atom. If I've got 5 protons, I will have 5 electrons. The 5 plus charges will be neutralized by the 5 negative charges of the electrons. So if I add plus 5 minus 5, what's my result? 0. That means that normal atoms have a neutral charge. They're neither positive nor negative. And that's super important, or else they wouldn't be very stable in nature. Okay? Now here's the cool part. Protons, okay, and this other mysterious green particle, well, I drew it green, that live in the centermost part of the nucleus, that centermost part of the nucleus, that is known as, okay, this is actually known as the nucleus. Okay, and nucleus just means center. Okay, so the protons and this elusive other particle that we're going to talk about live in the centermost part of the actual atom. Okay, so here's my nucleus. Now, my electrons live on those outermost rings. What did we call those rings? What were their names? When we talk about protons, protons are the little red circles, We're reminded that they live in the nucleus. Okay, they live in the nucleus with the green particles in this image that we're going to get to after we talk about where electrons live. Now, electrons live in these outer rings. Okay, we talked about the fact that these have two different names. Either is acceptable. Okay, they can be referred to as orbits, like a satellite orbiting the planet. Okay, it goes around and around and it stays on that ring. Okay, or these can be called energy shells, one or the other. Okay, these different rings. Now, in the case of magnesium, all right, I've actually, and the ring around the nucleus here, so if I draw this in purple, okay, this ring here, this does not include one of the energy shells. Okay, this is just the ring surrounding the nucleus. That's just holding the nucleus there. Okay, that is the nucleus. Now, the way electrons actually get stuck into different electron shells or orbits has everything to do with the periodic table. All right? If we look back at our periodic table here, okay, how many elements are there in the first period? There are 2 elements in the first period, hydrogen and helium. Okay? How many elements are there in the second period? The second period has 8 elements. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so there are 8. How many in the third period? 8. Okay, the same number right here. Okay, how many in the fourth period? 18. How many in the fifth period? 18. How many in the actual sixth period? Now, the sixth and seventh periods are a little bit different because not only do we start here, then we jump all the way down to these guys. All of these elements right here fit in this little area. And the way they fit is, imagine that you had a bendy ruler, okay? A ruler that you could actually bend. And imagine that you actually took that ruler and you actually, each one of those elements was a spot on that ruler. Okay, so all of my lanthanides are here, one after the other, and the beginning of the ruler starts at 57, and we bend it, and I won't do it with this one because it'll break. But imagine this, all of my elements are here, and they all fit into this small little space. Okay, don't ask me why. I didn't make the periodic table. I could probably find out for you, but I've never actually thought of looking it up. All right, so how many do we have in period 6? There are 32 elements in period 6. How many are in period 7? 32. Also 32. Now, these numbers are very, very important because in addition to being the amount of elements that there are in each period, they also help decide how many electrons go on each orbit. So we remember that we've got the same number of electrons as we do protons in any one atom. So in the case of magnesium, I look up to that little number that I've circled in the top corner of the box there, for my atomic number, which tells me the number of protons. I have 12 protons. Therefore, I must also have 12 electrons. And the way that this works in terms of the number of electrons that go on each orbit has everything to do with the number of elements on each period. So in that first orbit, we can only have a maximum of 2 electrons. In the second, and if your element happens to have more than 2 electrons, then you move to the next further out orbit or energy shell. That means that there's going to be a max of 8 electrons on that outside, on that next shell. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. So what's my total of electrons so far?
10.
I've got 10 electrons so far. I've got 2 here and I've got 8 here. What is my atomic number? 12. So how many electrons do I need to put on that third last shell?
2.
I need to add 2 more, 1 and 1. So now if I look at this element, I've got as many protons here as I do electrons. Okay, it balances out and it's supposed to. But look at these numbers, 2, 8. I would have a maximum of 8 on the next one. I would have a maximum of 18 on the next one, a maximum of 18 on the one after that, a maximum of 32, and then finally another maximum of 32. So if ever you're unsure of how many electron shells you're supposed to have in an atom, who knows? You may have to draw an atom. If you're unsure as to how many electron shells are supposed to be there, find your atom on the periodic table.